Hi there, welcome to question 10 of James Stewart's Calculus Early Transcendentals 9th edition. We're doing problem number 10 and the instructions tell us to differentiate, so we'll jump right in here. Basically, the question wants you to use your derivative table and practice the power rule. At this point, it's probably hoping you've memorized them, or at least you're able to locate them on a formula sheet. So the derivatives that we're going to need is that the derivative of e to the power of theta is just e to the power of theta. And the derivative of tan is sec squared. And the derivative of just theta is 1 because it's a variable. You treat it the same way with x. Alright, so we'll jump right into the derivative here. The first thing to note is that there is a multiplication between two terms involving the variable. So it's what's in the bracket there, and it's that e to the power of theta. Whenever you see a multiplication of two things involving the variable, it's a huge hint that you're going to have to use the power rule. So here's our three little derivatives in case you need them. The first rule is that you're supposed to take the derivative of just one of the terms. So I start by taking the derivative of everything in the bracket and leave e to the theta by itself. And then I leave everything in the bracket by itself and take the derivative of e to the theta. So with the first part, remember the derivative of tan theta is just secant squared theta, as you can see on the left. So I'm just replacing the tan theta with secant squared theta. And the derivative of theta is just 1. But remember, it's negative theta, so after you take the derivative, you have to keep that negative, and it becomes negative 1. On the second term, the derivative of e to the power of theta is just e to the power of theta again, so nothing really changes. At this point, I'm going to use a little identity here. You don't have to, but it makes everything look nicer. So tan squared is the same as secant squared minus 1, so I can take that secant squared minus 1 in the first term and just replace it with the tan squared. I don't know, it looks a bit nice to me. Now both these things are multiplied by e to the theta, so I can basically move the e to the theta out front and then just put the three terms together. So I have tan squared theta plus tan theta minus theta. And yeah, that's pretty much it. That's probably as simple and nice as you're going to be able to make it look. And that's how you do this problem. I hope this question helped. If you need help with another question, go ahead and comment what chapter and section below, or if you want, email me pictures of the problem and I'll try to solve it when I have the opportunity to. One thing I'll just mention here is that the important things I think they wanted you to remember is those three derivatives, and to identify that when you see two things with variables multiplied by each other, you're going to have to use the power rule. Hope that helps, and have a good day.